Variables are the absolute core to algebra. Without them, algebra simply would not be possible. In fact, that's not quite the truth. You could do algebra, and it was done long ago without variables, but it was much harder and it was not super deep. You could do some cool things, but most of the modern things we do with algebra happen because we have variables. It's important to know that a variable is a letter that is used to represent one or more numbers, so it could represent two. The numbers are the values of the variable. A variable expression is a collection of numbers, variables, and operations. So for example, you could have 8y, which is the same thing as 8 times y with a little dot, or 8 times y in parentheses. They all are the same variable expression. They're the same. This means 8 times y, and the operation is multiplication. 16 over b means 16 divided by b, and can also be written as 16 divided by b, although this is much more common, and the operation is division. Evaluating an expression is taking a value for a variable and plugging it in place of that variable. So if we were to evaluate these expressions, we would have 8 times 2 is 16. In this case, on b, we have 10 divided by 2, which is 5. Here we have 2 plus 3, which is 5. And here we have 14 minus 2, which is 12. So all we're doing is plugging in the known value for the variable in for where the variable is inside the expression. And remember that a variable expression is a collection of three things. It can have numbers, variables, and operations in it. You're not always going to be given a straightforward equation that you can evaluate. Sometimes you're going to have to take words and translate them into a variable expression. So in this case, we're going to try to find the average speed in miles per hour of a car that has traveled 180 miles from Boise to Minidoka National Wildlife Refuge in 3 hours. You're going to use the equation, which many of you are familiar with, which is distance equals rate times time, and isolate the r, which is the rate. In this case, we're looking at average rate because we have the overall distance and how long it took. You can speed up and slow down during a trip and still find an average rate. So in this case, you're going to divide both sides by t, and you end up with rate is equal to distance d over t. So what this means is average rate is equal to distance divided by time. In this case, this is the total distance, and total time. So we were told that the total distance was 180 miles, and the time was 3 hours. So what does that mean the average rate is going to be? 180 miles over 3 hours. 180 over 3 is 60, and the units are still going to be miles over hour, which should be pretty familiar because most of the time when you're in a car in the United States, the velocity, the rate, is measured in miles per hour. So let's evaluate a few more expressions. 6.3 when x is 3, you take the 3 and plug it in. 6.3 divided by 3, and that's going to be 2.1. 2/3, and when x is 1/3, you're multiplying fractions, so it's 2 times 1 on top and 3 times 3 on the bottom, which is 9. And here we have 60 over 12, which is 5. So it's pretty good to know your multiplication tables, don't you think? Sometimes you might get different units though, but that's not going to change how you use some of the existing formulas. So for 35, we're trying to find the average rate. To find the average rate, we need the distance, which is 75 miles, divided by 55 minutes. I guess I'll write miles out right there. So you can simplify that a little bit. The common multiple is going to be 5. So it's going to be 15 over 11 miles per minute. But you may think to yourself, I don't want miles per minute. I would like miles per hour. So let's write that out again. We have 15 miles per 11 minutes. The only thing you can multiply something by and keep it the same is 1. So I'm going to multiply by it. I'm going to pick this. It's going to seem a little strange, but 60 minutes over 1 hour. 60 minutes over 1 hour is 1. It's the same thing. 6 over 6 is 1. 7 over 7 is 1. A pony over a pony is 1. It is 1. This expression is 1, so when I multiply by anything else, that's not going to change the value of 15 miles over 11 minutes. What's nice about this is that since you have minutes on top and minutes on the bottom, they cancel, leaving you with 15 times 60 miles, that's what's left on top, over 11 hours. So now we have 15 times 60 miles over 11 hours. So that is miles per hour. So the answer would be 15 times 60 over 11 miles per hour, which you can write as MPH if you'd like. Now to simplify this, it's a little tricky because there's no common factor. There's no way to simplify that. But if you use your calculator, you end up with, and you're going to have a decimal here, and I would like you to go to 3 decimal places, 81.818 miles per hour. So what's interesting about that speed is it's pretty fast. And if this was a car, you'd definitely be breaking the speed limit somewhere along the way. But it's a train, so I guess it's okay that it's going 81 miles an hour. So the next one, though, is an athlete runs 40 feet in 5 seconds. 40 feet in 5 seconds. That's the average rate, because this is the distance over the time. Well, 40 over 5 is just 8 feet per second. And we're going to keep it like that because feet per second is a pretty common unit of measure for velocity. So remember what a variable is. It's just a letter that's used to represent one or more variables. And a variable expression contains 3 things: numbers, variables, and operations. When you're evaluating an expression, you just take the value and plug it in for the variable. And sometimes you're going to have to go from words to variable expressions, which then you will evaluate. With this word problem in particular, we're using distance equals rate times time, which is a really common formula that will come up again and again. Make sure you deal with decimals properly, and when you can, as it happened right here in the last, go to 3 decimal places. There are 3 decimal places right there. And be careful of your units. Miles per hour are a great unit, although miles per minute is perfectly acceptable as well, unless I tell you you have to convert to miles per minute. I hope you found this helpful.